This device generates electricity from darkness. Scientists have created something of a reverse solar cell, a tool that generates electricity from the darkness of night. As energy and how humans produce it continues to be an important modern conversation, a team of researchers have branched way out, trying to harness energy from whatever sources they could. They were able to generate enough electricity to power an LED using $30 in equipment, thanks to something called radiative cooling. The amount of power coming in from the sun has to be approximately equal to the amount going out from the Earth as thermal radiation, in order to keep the Earth at a roughly constant temperature, study author Shanhui Fan, Stanford electrical engineering professor, told Gizmodo. The amount of power available for harvesting is very large. In their paper, published in JAWL, the researchers point out that 1.3 billion people lack reliable access to electricity. And though solar cells exist, these communities require lighting at night, and the need for battery storage from solar panels to use the energy later drives up costs. Instead, the researchers devised a means to create electricity at night on the spot. Solar panels commonly generate electricity from the sun through a physical process called the photovoltaic effect. Light exposure on certain materials generates an electric current, but others work through thermal processes. The sun is hotter and Earth is cooler, and the difference in temperature can be converted into usable energy. The researchers devised a system based on the alternative process, in which Earth is the source of heat. The system is made from a 20 cm, 8-inch, aluminum disc painted black and hooked up to commercial thermoelectricity generators. These discs are radiation emitters, and are typically several degrees cooler than the ambient air. Heat flows from Earth and into the air, and then from the air through the thermoelectricity generators and into the disc, which then radiates the heat upwards. The test in California was able to generate 25 milliwatts per square meter of the disc, enough to power one small LED. During the daytime, the device could act in reverse, absorbing sunlight and producing electricity from a heat traveling from the sun to the disk and into the outside environment. This is just a proof of concept. With more insulation and in more optimal conditions, like a drier climate, the researchers think they'd be able to bring this up to 0.5 watts per square meter of disk. With larger disks, they might be able to light a home continuously. This isn't really comparable to solar energy, which can generate maybe 100 times more power than this device operating. At its limit, according to study author Adiswath Raman, an assistant professor of materials science and engineering at the University of California, Los Angeles. But it's cheap, and would be able to operate for longer than a battery could. And of course, it provides a way to generate electricity at a time that solar panels can't.